Hello, everyone. This video is going to help with 7.1, which is estimating a population's proportion. So our key idea for this section is we're going to present methods for using a sample proportion, okay, to make inferences about a value of the corresponding population proportion. Here are the three main ideas. So what is a proportion? It's saying so many out of so many, like 200 people out of 1,000 say they don't own a TV. So we're going to have some kind of proportion of information. And what we can do is we can use a sample proportion. So we get a sample, just like we've been talking about in a lot of our sections, and it's a sample proportion. And then we're going to take that information and make things about the whole population, make inferences about the whole population. So the first idea is we have a point estimate. And this is either a standard deviation, a mean, a variance. It's some kind of statistic that we can use. So when they talk about a point estimate, they're talking about some kind of statistic that we can use to make estimations about our population. So our sample proportion is a estimate, our proportion. And we use this little p hat for our sample proportion. We use p for our population. Okay. Then we're going to talk about confidence intervals. And we use the idea of a sample proportion to construct our confidence interval. I'll give an example of that in a second. But what is a confidence interval? It's like saying, I am confident based off this sample that the population is between two numbers. So like if I say, I'm saying that when I use a sample, I'm off a little bit. That's how I like to think of it. Like I'm between these two values. That's how confident I am that you're there. So that's kind of the idea. So for example, let's read one real quick. We must be careful to interpret the confidence intervals correctly. There is a correct interpretation and many different and creative incorrect interpretations of a confidence interval. So if I'm saying the population, not the sample, notice the P doesn't have the hat. The population is between these two values. Okay, so the population proportion is between these two values. I am saying the correct way to say this is I am 95% confident because that could be 99, it could be 90, but for this one I use 95. We use 95 confident that the interval from this number to this number actually does contain the true value of the population proportion P. We are 95% confident that the true population is between these two numbers. That's the correct way to say it. So whatever confidence level I use, so that confidence level, it depends on you. You can say, I'm fine with 90% confident. Or you could say, I want to be 99% confident. So your interval could be a little bit tighter at 99% and a little bit further apart at the 90. Okay, so if I'm talking confidence intervals, we can state it two ways. We can say you're between the two numbers like we see here. Or we could state it, like this one here. I was confusing myself for a second. Or we can state it as we're plus or minus our samples population proportion. Goodness, so I didn't quite say that right, but this notation up here is saying you take the samples proportion. So I gather my data, I have the sample, right? And I'm going to add my error and subtract my error. See, subtract on the lower, add on the higher, and that's how I get in between these two. When we get an example, you'll see what I mean a little bit better. But basically, we have to figure out our error and then add and subtract it to our sample's proportion. And then our error is found by this. Okay, so we need to know what all this stuff means. Getting there. So sample size, we should know sample size is just the number of people in your sample. Okay. Critical values. Oops, this one needs to be changed to a 6. So this is 0.2.576. So where did I get these numbers from? I went to Statcrunch, it's normal calculator, and well, I stole these from the PowerPoint, but that's how you could get them. You go to the normal calculator and you need to use the between, because I am 90% confident, but it's like between the two, okay? And so this is just putting in the 0.9 and getting what value your Z is, and so forth. And they had an error on the PowerPoint. So if you read the PowerPoint, be careful. I was like, hey, that number's off. So here's some 3 basic ones that we could use throughout our formulas. Okay, so here's some notation. If I use P, I'm talking the population's proportion, and Q is going to be 1 minus that. If I'm talking the sample, I add the hat, so I could also say Q hat is equal to 1 minus P hat. That's called a hat. It does look like a hat. Okay, so basically the relationship between P and Q is 1 minus. So if I say there's a 45% chance of it raining today, then the other one would be 55, right, between the two. So going back to those probabilities and knowing they add to 1. Same idea here. A proportion is a probability of our, population. So N is just your number of samples. E is that margin of error, and we have our formula for that. So we're going to be given this critical value. So you're going to have to go to that table and get your critical value, or use the normal calculator if it's not one of our traditional. Usually it's 90, 95, 99. And I mean, but if it happens to be 98 and you don't have that in your notes, use that normal calculator to get that critical value, or Z, or area under the curve, or yeah. Okay, so we would take our P times our Q divided by our N and times it by that value. You can also find this if you have your confidence interval. You can find this by taking your, it didn't quite print on here, the high minus the low on your intervals and dividing by 2. High minus the low and dividing by 2. So if you have your confidence interval, you can find your error that way. So this is, I don't have my confidence interval, just what's the error. This one is, I have my confidence interval, what's my error? You could still use this, but we have this other way as well. So I do want to point out, there's a couple questions in the homework like that just use this notation, Z, and then their theta divided by 2. And what's that saying? It's critical value two-tailed. So we want in between, because you're two tails. So use the between section in the Statcrunch normal calculator. So if I say Z to this equals what out of the 87%? Let's bounce over to Statcrunch and see that real quick. Okay. And there's this weird clicking in my ear right now. It needs to stop. Okay, so go to Stat Calculators, Normal. Normal is always Z normal. We want between, and this one said you want 87.87. We don't put in a mean and standard deviation because we are looking at Z, so it's standardized. So we don't have a mean and standard deviation, so we use the 0 and 1. So what is the value? It's 0.51. We just use the positive. Okay, so then let's bounce back over. And you can see my answer of 0.51. So I got my critical value with the normal calculator, which we did in our last sections. It was on our last exam. All right, so let's do some examples to try to hopefully make this a little bit clearer. So problem 1, what's the confidence, or the confidence interval is between 5 and 10, okay? What was our margin of error? So I'm given the confidence interval. So we go up here to margin of error and we have two things, formula, or it says if you have the confidence interval, you take high minus low, divide by 2. So we're going to take high minus low and divide by 2. So to get our margin of error, we're going to do 10 minus 5 divided by 2. So we're going to have 5 halves, or 2.5. That's our margin of error. What if, this isn't asked on here, but it is on your homework, so I want to add this. What if I want it in the form of p hat plus or minus the error? P hat refers to your sample's proportion. And we don't know that. So the way that we can find that is we take and find halfway between these two values, because halfway plus the 2.5 plus the 2.5 would be about where we're at. So we would go 10 plus 5 divided by 2. Halfway would be 7.5, right? 15 divided by 2. So we could write this as 7.5 plus or minus 2.5. How do I check if that's right? 7.5 plus 2.5 is 10. 7.5 minus 2.5 is 5. This is just another way of writing my confidence interval, and I wanted to show that on this example. So on your homework, do you ever see like the example plus or minus 0.05 or something like that on those technology My Math Lab questions? What it's saying is you might have a margin of error when you round on an answer that doesn't have an exact. So it's giving it in this form kind of a lot too. Usually it's within like one decimal place, so it might be like within 0.1 plus or minus, or 0.01 if it within 100. Okay, so you'll see that a little in real life. If 250 people out of 2,521 people said they like math, that's kind of low. I bet it's even lower. Everyone, when I tell them I teach math, they say, what? I'm like, yes, and I like it. Use the confidence level of 95%. What is our population proportion? So this one is giving us that proportion from, I don't know, a survey or something. This is representing our sample. Okay, and so what is the population proportion? It would be the 250 out of 2,521, or it could be our full population. I guess I shouldn't say it's our sample, but I mean, typically it's our sample. So 250, we divide that by 2,521, and I get 0.0992-ish. Okay, so that's just our proportion. We just divide it. It's like finding your probability. What's the probability of liking math? About 10%, right? 0.0, if I round that up, about 10%. What is the margin of error? So I want to do this with the formula this time because I don't know the confidence interval. So the formula says to take your critical Z and times it by the P and Q divided by N. I switched those. I didn't mean to. It doesn't really matter the order on the P and Q. Okay, so how confident are we? 95. So we'd either need to go to our normal calculator and figure out that value, or I wrote some down in your notes. So for 95, it was 1.96. Okay, you're going to get good at those three. You have to use them a lot. And then times that by, so if this is P, what's Q? It's going to be 1 minus that. So 0.0992 minus 0.0992, and then I subtract the 1, and I get 0.9008. Okay? Oops, I wrote minus. Just because I said I minus the 1, and then I wrote minus. We times those two. Okay, so how did I get these? They add to 1. You have to do that quite a bit on these formulas. And we divide it by 2521. 2521. Put that all in my calculator. I magically get 0.012. So my margin of error is 0.012. Very small. Okay. So that means, let me say this wording exactly like how they want so I don't mess it up. We are 95% confident that the population proportion is within 0.012. Okay, is within, has an error. Well, we could do our confidence interval. Let's do our confidence interval because it'd be between these two. Yeah, I really need to know it's within this much of this. So I didn't quite say that right, but you're using that same wording of you're 95% confident the intervals between these two for the true population is between those two, the true population. So what is our confidence interval? So our confidence interval, we know our population proportion. So we have our 0.0992. We're going to add this 0.12, and we're going to subtract that to get two values of 0.111 and 0.087. So what did I do? I took my proportion and I added and subtracted my error to say that right this way, my population is within these two values. So my population is within these two values for my confidence interval. So I'm confident at the 95% level that everybody who likes math is between about 8% and 11%. See? So what did I get? I got about 10% on my sample. And I said, okay, the true population is going to be within these two because of that error that we have. Okay, the error is going to be bigger the lower your confidence interval. All right, we could have written this as 0.0992 plus or minus 0.12. That's just the two ways to write my confidence interval. We typically will see it this way 99% of the time, but I want to make sure you understand that too. Okay, because that's what we did. We added and we subtracted. All right. All right, in my note sheet, if you print it off, there's another example for you to try. I'm not going to do it on the video, but I am going to take a second and show you the problem we just did in Statcrunch. So stop share, share again, and boom, hopefully we're there. Perfect. Okay, in Statcrunch, we can find our confidence interval. Margin of error is a little different. Can't quite see it, but we go to stat, and what do we have? We have a proportion. Okay, that's going to become important when what if I have a mean or I have anything else but a proportion? We'll have to go to something different. So we have one sample and we have a summary of data. So what did I go to again? Stat, proportion, one sample with summary. And look, it says number of successes. So we said 250 people out of 2,521 people. And we don't know about hypothesis testing yet, but eventually we will. And this is the exact same place you're going to go. We are confidence interval, and we are 95. Yeah, 95%. Leave the rest the same, and we say compute. So look here. It gives us that sample proportion, which we wrote down already. And then it says your lower level and your upper level, which we found. And honestly, you could do this. You don't have your margin of error, but can't I subtract these and divide by 2? Yeah, let's do it real quick. So get out your calculator. Boop, boop, boop. And I'm going to say 0.1108 minus 0.0874, that should be a 5, and then divide it by 2, and I get my margin of error, which we said is 0.012, 0.012 when you round. Perfect. So you could get your error on Statcrunch as well. So you could get your confidence interval, you could get your error. You can use Statcrunch. Why am I showing you a formula? Because a lot of people struggle with the calculators with Statcrunch, and they just prefer a formula. And I want you to kind of understand better where everything's coming from versus just plugging it in and getting it. All right. Okay. So I have one more idea here. What if you don't know how many people to sample? I don't know. I do not know my sample size, so I need help determining it. I want to be confident that I have sampled enough people to work for my whatever level I pick. So I'm going to ignore this part just for a sec, that just showing Statcrunch, which I'm going to actually show. But we have two formulas. We, if we know our estimated population proportion, or if we don't know it, here are my two formulas for that. Okay, they're a little ugly, but you still have your confidence interval, critical value, right, with your Z. I said confidence interval. I'm losing my mind. Your critical value, your Z, from the normal calculator. I meant to say normal, but squared, and then we've done the PQ before, and we're going to divide it by our error. If I don't know the P, I use 0.25. There you go. Where does 0.25 come from? Well, it comes from 0.5 times 0.5. So you just assume they have equal probability. 0.5 times 0.5, that's where that 0.25 comes from. So that becomes a little bit important when we put it into Statcrunch, because it's 0.5 is what you estimate in Statcrunch. Okay, so when an author is conducting a research for this chapter, he could find no information about the percentage of adults who make online purchases. Yet that information is extremely important to online stores as well as brick and mortar stores. If the author were to conduct his own survey, how many adults must he survey in order to be 95% confident that the sample percentages is an error no more than 3 percentage points? What do I have to have? My critical value, like how confident am I? 95. And I have to have the error that you're willing to have. So this person says, I want to be within 3%. So this, ignore this if you printed it off. This is the answer. Do I have a blank paper? Sure I do. We're going to actually calculate it ourselves. But it does cheat and kind of give you the answer on the print off if you print it off. Okay, so what are we going to do? We know, assume the recent poll shows that 80% of the adults make online purchases. So this one gave us our population proportion. It already divided it, and it said it's 80%. So when I go back to a decimal, I need to use 0.8. Okay, what is our Z? We need this one, but what is our Z at 95%? 0.1. 1.96. So we have that 1.96 squared times our 0.8 times, what's 1 minus 0.8? 0.2, they add to 1. The whole thing divided by my error squared. My error is no more than 3%. So that is 0.03 squared. All right, so we plug this into our calculator and I get 692.951, which we always round up, always. 682, I mean 3, then I rounded down. Always round up because I have to sample enough people. So if I have any decimal over there, I have to add one person. I can't sample 0.9 of a person. So I'm going to have to sample 683 to be confident within 3% level, within 3% of our error at a 95% level. Okay, so the next one says, assume that we have no prior information suggesting possible values for that population proportion. That seems a little bit blurry. There it goes. So assume that we have no prior information. So we have no other information. Then I'm still going to have to use that critical value for 95, which we said was 1.96 squared. But what do we times it by? We just assume 0.5 and 0.5, which we times together and get 0.25, all over the error, which was 3% squared. And what am I going to get? 1,067.11. So we use 1,068. So I need to survey 1,068 people. So it's a little bit different from using or knowing the population proportion. So we went from, what was it? 683 to 1,068. So it does make a little bit of a difference on how many people you have to sample for this one. The closer you are to 0.5 proportion, that probability, the more it doesn't matter if you know the population proportion. Oof, let me show you that on Statcrunch. Okay, so we're going to go to stat. I push this stuff away, but I actually have to know. And we're going to go to proportion, one sample, but width or sample size. Width or sample size. So what we're going to put, I don't know where. Why did it do this? I was thinking maybe I accidentally got out of recording, which would really not be good. You wouldn't know because I'd have to re-record. So one sample with sample size. Okay, move this over again. I must have clicked on something over here. So we do want the 95. And on the first one, we wanted the sample to be 0.8. And the width is tricky. So the width is 3%, but 3% on both ends. 3% on both ends. Within the 3 is 0.06. So you have to times it by 2 to get the 683. Okay, let's do the same kind of idea, but this time we don't know the target proportion. So we use the 0.5 because we said 0.5 times 0.5 is the 0.25 in the formula, and the same width, and I get 1,068. This works awesome for proportions, but when we do the in size of the other ones, Statcrunch doesn't give us the right answer. So works great for this one, but not so much for the others. All right.